Hello everybody, so today in this video we're going to do two differential problems and one initial value problem. So let's start off with our first differential, which is dy dx equals sine x plus 1 over x minus secant squared x. So the first thing that I'm going to do is multiply by dx on both sides. And I'm left with dy equals sine x plus 1 over x minus secant squared x times dx. Now I'm going to go ahead and take the integral of both sides. And I get y equals the antiderivative of sine x is negative cosine x plus the antiderivative of 1 over x is the natural log of x minus the antiderivative of secant squared x is tangent x. And then since this is an indefinite integral, meaning that the upper and the lower bounds are not defined, there will be a plus c at the end. And that is what you write as your answer. The second problem is a little bit harder. D squared y over dx squared equals cosine x plus x squared minus 1 over the cube root of x. So I'm going to again multiply by dx squared on both sides to get rid of that denominator here. Then I'm left with d squared y equals cosine x plus x squared minus 1 over the cubed root of x, not 3. And I'm going to take the integral, and I get dy equals the antiderivative of cosine x is sine x. The antiderivative of x squared is x cubed over 3. If you don't remember how to figure that out, it's always n, or the power plus 1, divided by n, or the power plus 1. So that's x cubed over 3. And then same thing for this portion. You can write 1 over the cubed root of x as x to the negative 1/3. So I would add 1 here. And that ends up giving me minus 3/2 x to the 2/3 plus c. And we're going to call this constant c1 because there will be another constant when we take the integral of this whole thing so that we end up with y. So we really want to make sure we're keeping our constants in place, I guess. So let's go ahead and find the integral of dy, which is y equals antiderivative of sine x is negative cosine x plus antiderivative of x cubed over 3 is x to the 4th over 12, again using this rule that we did there. And then the antiderivative of 3/2 x to the 2/3 is 9/10 x to the 5/3 plus the antiderivative of constant is constant sub 1x. And then we will have our other constant, which will be labeled c sub 2. And this is your answer. Okay. So now on to our last problem, which is the initial value problem. For your initial value problem, well, the problem is dy dx equals 1 over 1 plus x squared. And it says, given y of -1 equals 1. So similar to the differentials, I'm going to multiply by dx. dy equals 1 over 1 plus x squared times dx. And then I'm going to take the integral, and I get y equals the antiderivative of 1 over 1 plus x squared is tangent inverse of x, then plus c since this is indefinite. So now the next step is to remember that they had given us y of -1 equals 1, and this is important because we can solve for the initial value, which is the c value. We plug in -1 for x, and we plug in 1 for y. And this way we can find the c, or the initial value. So 1 equals the tangent inverse of -1 is negative pi over 4. And then I would add pi over 4 to the other side, and I get my value for c. So pretty straightforward and simple there. But this isn't how you answer the problem. You answer the problem with an actual y equals blah 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 equation. So the actual answer to the problem, I'm going to write in yellow, is y equals tangent inverse x plus 1 plus pi over 4, which was that c value. So these are synonymous, except I actually found the c value in this one. All right, so as usual, if you have any questions or would like to request a video, please let me know in the comments. Thank you.